Okay, today class we will be taking T-notes on ions. And an ion is simply when an atom gains or loses an electron. Now we know that an atom usually has the same amount of protons and electrons. However, when you lose or you gain an electron, you will have a different charge on that atom. When an atom gains an electron, it becomes negatively charged because when you gain an electron, you will then have more electrons than protons. However, when an atom loses an electron, then it will have more protons than electrons, therefore becoming more positively charged. Why do atoms gain or lose electrons? Atoms want 8 valence electrons in its outer shell. Remember, in its valence shell. Or if it is 1 electron shell, then it will want 2 electrons in order to be stable. Here is an example, and yes, please draw this and write all this down. When you're looking at hydrogen, we know that hydrogen has only 1 electron, and it's in its valence shell. So we have 1 electron in its valence shell. In order to be stable, this atom will actually want to have 1 more electron, therefore having 2. If it has 2 in its valence shell, then it will be stable. In this case, because there is only 1, it can either give or take an electron in order to be stable. Most of the time, hydrogen is known to give its electron in order to be stable. Let's look at boron. We know that boron has a total of 5 electrons from looking at the atomic number on the periodic table. The electron configuration for boron is 2, 3, which means that in its first shell, we have 2 electrons, and then we have the remaining 3 electrons, which are known as the valence electrons, in the outer shell. So we have 1, 2, and 3. In order to get to 8 in this valence shell, it would be easier for this atom to give its 3 electrons than to try to get 5 electrons from another place. With fluorine, we know that fluorine has 9 electrons, and its electron configuration is 2, 7, which means 2 electrons are going to be in its first shell, and the remaining 7 are in the valence shell. So we have 7 valence electrons. In order for it to be stable, it would be easier to take 1 electron than to give. Here is another example for you to look at, and I'm going to just go ahead and show you how the protons, neutrons, and electrons and the overall charge changes when we take out an electron. So here we have sodium, and sodium has 11 electrons total from looking at the atomic number on the periodic table. From that, we know that we have an electron configuration of 2, 8, and 1. So 2 electrons in its inner shell. Second shell has 8, and we have a remaining valence electron in the valence shell. Over here, before we do anything prior to any chemical reaction, the atom has no electrical charge, and this is because we have 11 protons, we have 11 electrons, and the neutrons are neutral, so they don't count. These would cancel each other, and we would have a total charge of 0. If we were to have sodium give its electron away, now we would have 11 protons, we would still have 12 neutrons, and now we would have 10 electrons. So as you can see, we have a positive 11 from the protons and a negative 10 from the electrons. And when we subtract this, we do have a difference. We have more protons, therefore we have a positive +1 charge. Okay, we've come to the end of our T-notes. Thank you very much for watching. Be ready to use this information in class.